Hello dear students, welcome to Tejo my YouTube channel. In this video, I am going to solve numericals on Young's Simplicity experiment. So this is the third video that I am making on this particular topic. I have already made two more videos and I have already uploaded them in the YouTube. If you have not watched them, please do watch them and come back to this video. Okay, in the first video, I have explained how interferences fringes are formed in case of Young's Simplicity experiment, and what kind of formula that you have to use to solve any kind of problem in this particular topic. Okay, in the second video also I have solved different kind of numericals which I have selected from the previous year question papers. Okay, in this video also I am going to solve few more numericals on this particular topic. Why I am solving more and more problems on this particular topic is because it is one of the most important chapters from which you can expect 5-mark numerical. Okay, so if you have seen, if you have observed the previous year question papers of Karnataka board examination question paper, so you can see from the last 7 to 8 years they are continuously giving one pakka 5-mark question from this topic. Okay, and this time the blueprint is fixed and you may get 100% one numerical from this particular topic. Okay, so without wasting time, let us start the video. We got a question here. Let us solve this. In Young's deposit experiment, the slits are separated by 0.28 millimeter and the screen is placed at a distance of 1.4 meter away from the slits. The distance between the central bright fringe and the fifth dark fringe is measured to be 1.35 centimeter. Calculate the wavelength of light used. Also find the fringe width if the screen is moved 0.4 meter towards the slits. Mark it, okay, towards the slit for the same experimental setup. So here they have given this data, dear students. Small d is equal to 0.28 millimeter, means 10 to the power minus 3 meter. Capital D is given. This is the distance between screen and the slits, 1.4 meter, and distance of fifth dark fringe is given. I have already told you in the first video that in case of dark fringe we have to take one value less. Then we have to take fifth dark fringe, means we have to take n value as 4. X4 is equal to 1.35 centimeter and lambda is equal to how much? We need to calculate it. So d dash is equal to d minus 0.4 means this is the new case. If the distance between the slits and the screen is decreased by 0.4 meter, then what will be the new fringe width? So let us calculate lambda here. So we have the formula xn is equal to just a minute, 2n plus 1 lambda d by 2d. So this is the distance of nth dark fringe. Okay, distance of nth dark fringe formula from the central bright fringe. So xn is given. How much is that? So 1.35 centimeter means I will directly substitute to the actual value, that is 10 to the power minus 2 meter. That is equal to 2 into n value we have to take 4. So 4 plus 1. Okay, into lambda we need to calculate. Capital D is given 1.4 meter divided by how much is that? 2 into small d. Small d is how much? 0.28 into 10 to the power minus 3 meter. So here meter will cancel out, this meter will be there. Okay, now dear students, we need to calculate lambda, therefore we have to take all other values this side. So lambda value will be this much. So 1.35 into 10 to the power minus 2 meter will be there, into this will come this side, 2 into 10 to the power minus 3 into 0.28. Alright, 0.28 first, 0.28 into 10 to the power minus 3 divided by, this will come down along with this one. 4 2s are 8 plus 1 is 9 into 1.4. So if you solve this, you will get the value as 600 into 10 to the power minus 9 meter, or 6000 into 10 to the power minus 10 meter. So I can write here the value of lambda is 600 nanometer or 6000 angstrom. Just solve this, dear students. If you solve this, you will get this value for sure. Okay. Now, if d value is decreased, if d value is decreased by 0.4 meter, what will be the value of beta? Okay, let us calculate it. So we'll erase this, okay, and we'll solve beta. Okay, dear students, we have got the value of lambda, that is 6000 angstrom or 600 nanometer. Now calculate the value of beta here. So beta is given by lambda d by small d. So what is the value of lambda? 600 nanometer. 600 into 10 to the power minus 9 meter. But here in this case, d value is decreased by 0.4 meter. Let me write this is d dash. So d dash is given by d minus 0.4 divided by small d is given. So that also we have to substitute. So let me write here. So that is beta is equal to lambda value is 600 into 10 to the power minus 9 into d value is 1.4 minus 0.4 will give you 1 divided by small d value is how much? 0.28 into 10 to the power minus 3. So if you solve this, beta value will get 600 into 1 divided by 0.28 will get somewhere around 0.21 into 10 to the power minus 2 meter means 0.21 centimeter. Beta is equal to 0.21 into 10 to the power minus 2 is nothing but centimeter. Okay, so this is the fringe width value. Hope you people have understood this particular concept, dear students. First we have to calculate lambda value. By using that we need to find out beta value. But here one change is d value is decreased by how much? 0.8. See here, dear students, if they give d value is decreased by some particular value, you have to subtract it. And if d value is decreased to, it is different meaning. It gives different meaning. If d value decreases to 0.4 meter means you have to directly take this value as 0.4. Decreased by means you have to subtract by the actual value. So this is the case here. Now let us solve one more question. So here I have got this. In Young's double slit experiment, the slits are separated by 1.2 millimeter and the screen is placed at a distance 0.75 meter away from the slits. The distance between the central bright fringe and the fifth bright fringe is measured to be 1.8 millimeter. Calculate the wavelength of light used. Also, find the distance of fifth dark fringe from the center of the screen. So the concept is very clear. Okay, they have given this particular data and they are asking you to find out lambda, and also they are asking you to find out the distance of fifth dark fringe. I have already told you, if you are going to use this formula, then we have to take one value less for n value. Fifth dark fringe is n value 4. Sir, what if we have to use only this value only? 5 only I have to use means you have to write minus here. Okay, then 2n minus 1 means you can directly substitute n value as 5. Okay, if you are using plus, you have to substitute n value 4. Okay, now by using this data I am going to find out lambda first. So they have given the distance of n, the bright fringe. Let us calculate the lambda value by using that. Here we have for bright fringe we have the data, that is n lambda d by d. So from that I can write for lambda is equal to, d will come this side, n will come down, capital D also will come down. Lambda is equal to xn into small d divided by n into capital D. So here for fifth bright fringe, xn value is 1.8 into 10 to the power minus 3 meter into small d value is 1.2 into 10 to the power minus 3 meters, and n value is 5 into capital D value is 0.75 meter. So meter will cancel out. If you solve, you will get the data somewhere around. Let me give the final answer. You can make use of the calculator and solve it, or directly you can solve it. So you will get 0.576 into 10 to the power minus 6 meter. Don't blindly believe me. Okay, just solve it. If you are getting the same value, it is acceptable. So lambda is equal to, then you will get somewhere around 5 76 into 10 to the power minus 9. If you shift the point, you will get 10 to the power minus 9 meter. So usually we have to keep the lambda value in angstrom or nanometer. Here we are getting 576 nanometer. This is first case. They are also asking me to find out the distance of fourth dark fringe. So let me calculate it. So xn is equal to 2n plus 1 lambda by 2. 2D formula is there. Let me substitute the value directly. Distance of fifth dark fringe. So that is 2 into 4. 2 into 4 plus 1 lambda value is that you have calculated here 576 into 10 to the power minus 9 meter into capital D value 0.75 meter divided by what do you have 2 into small d. Small d is 1.2 into 10 to the power minus 3 meter. Again meter will cancel out. The distance of fourth bright fringe you will get dark fringe you will get somewhere around 1620 into 10 to the power minus 6 meter. Let me keep it in millimeters. 1, 2, 3. So that is 1.620 into 10 to the power minus 3 meter. So therefore x4 is equal to 1.62 millimeter. So this is the distance of fourth dark fringe, and this is the distance of fifth dark fringe. So fifth bright fringe, fifth dark fringe. Fifth dark fringe. So this is how we have to solve this particular problem, dear students. You people have understood this. So if it is done, let us move on to the next problem. Okay, dear students, let us solve the next question. In Young's double slit experiment, the wavelength of light used is 500 nanometer and distance between the slits is 2 millimeter. Distance of the screen from the slits is 1 meter. Find the fringe width and also calculate the distance of seventh dark fringe from the central bright fringe. Okay, so we need to find out fringe width as well as the distance of nth seventh dark fringe. I told you if you are using plus here, take one value less here, n value of 6. If you are using minus here, you can directly substitute n value of 7 for dark fringe. For a bright fringe there is no confusion. For dark fringe only, so you have to change it. Now if you find beta first, we can directly make use of this formula. That is beta is equal to lambda d divided by small d. That is equal to lambda value is given 500 into 10 to the power minus 9 meter, and capital D is given 1 meter divided by small d is given 2 into 10 to the power minus 3 meter. So 250 is 500. So that is equal to 250 into 10 to the power minus 9 into 10 to the power minus 3 will go to the numerator as plus 3. Now if we solve this, beta is equal to 250 into 10 to the power minus 6 meters you will get. So R 0.25 into 10 to the power minus 3 meter, R 0.25 millimeter you will get. So beta value you will get as 0.25 millimeter. Now we also have to find out the distance of seventh dark fringe. Let me take that formula. Xn is equal to 2n plus 1 lambda d divided by small d. So x6 I'll write here. X6 is equal to 2 into 6 plus 1 into lambda value is that we have already calculated. Now it's given. So 500 into 10 to the power minus 9 meters into capital D value is 1 meter divided by small d is also given. So that is 2 into 10 to the power minus 3. So as we have done here in the previous case, so 250 is so 250 into 6 2s 12 plus 1 13. So x6 is equal to 13 into 250 into 10 to the power minus 6. That is equals to, if we solve this, So I'm going to directly give you the value. I think you will get 1625. Yes. So 1625 will get 1625 into 10 to the power minus 6 meter, and the x value should be we usually keep it in millimeters. So 125 into 10 to the power minus 3, because I'm going to shift the points, so we'll get millimeter in terms of this one, that is 1.625 millimeter. That's it. So this is the value of 7th dark fringe from the center of the screen. Okay. I hope this is also clear to you all. Okay. Now let us solve the one more question. Okay, dear students, we got the question like this. Two narrow slits separated by 0.2 millimeter are illuminated by a light of wavelength 400 nanometer. An interference fringe pattern is obtained on a screen placed 2 meter from the slits. Find first one, the fringe width. Second one, actually it's not now, it is new fringe width when the slits separation is hollow, means the slit separation is reduced to half of the previous value. And also find the change in fringe width. Okay, so let us solve this. Here the data given is like this: small d is given, lambda is given, capital D is given. So we need to find out beta. Very easy. Beta is equal to lambda d by small d. Let us solve this. So lambda is how much? 400 nanometer. 400 into 10 to the power minus 9 meter divided by small d. Small d is given, how much is that? 0.2 into 10 to the power minus 3 into capital D value is also there. So that is 2 meter. So here we can cancel 2, 2. So we'll get 0.1 here. So 400 divided by 0.1 is 4000. So beta is equal to 4000 into 10 to the power minus 9, 10 to the power minus 3. So we'll get minus 9 into 10 to the power minus 3 will go up plus 3. That is equal to 4000 into 10 to the power minus 6 meters. Micrometers, or I can convert it into millimeters also. 1, 2, 3, 4 millimeters. 4 into 10 to the power minus 3 meters or millimeters. Okay, this is fringe width. Now we need to find out the new fringe width when the d value is reduced to half. So second question that we need to answer here is beta dash when lambda d divided by small d divided by 2, because the d value is reduced to half. Now here 2 will go up, 2 into lambda d by small d. So we have already solved lambda d by small d. Lambda d by small d value is this much, this much, this much or this much. So 2 into lambda d by d value is beta, that is 4 into 10 to the power minus 3 divided by that's it. Okay, so 4 to the 8. So new fringe width is beta is equal to 4 to the 8 into 10 to the power minus 3 meter or millimeter. Now also we need to find out change in fringe width. So that is C, change in fringe width is equal to beta dash minus beta. So 8 millimeter means 10 to the power minus 3 meter minus 4 millimeter. 4 into 10 to the power minus 3 meter. So change in beta is equal to 4 millimeters or 10 to the power minus 3 meter. So this is how this problem is solved. Okay. So this is the fourth question that we have solved here, and the last one I am going to give you as homework. If you have watched this, we have solved this. Okay, try to solve the fifth one, and if you get the answer, please do text that in the comment section. Okay, and if you want any other questions to be solved on any other chapters of second PUC, you can comment in the comment section. I will try to solve the most important questions on those particular topics. Okay, now let me read out the next question. Two slits separated by 1 millimeter in Young's double slit experiment are illuminated by the violet light of wavelength 400 nanometer. The interference fringes are obtained on the screen placed at 1 meter from the slits. Find the fringe width. If the violet light is replaced by the light of the wavelength 700 nanometer, find the percentage change in the fringe width. Okay, so this is the question which was asked in May 2022 in the Karnataka board examination question paper. So try solving it and find the answer. So we'll meet in the next video. Till then, take care. Bye bye.